Hello, everyone, and welcome to Chapter 7 of this Flutter course. In this chapter, we're going to talk about advanced Dart concepts, things such as extensions, features, streams, um, async await generators, and generics as well. So, uh, I'm kind of assuming that you've already set up the project that we've talked about in the previous chapter, so I'm not going to go through that again. And then I'm assuming that we have like some sort of an iPhone simulator, or an Android emulator, or any device that you may be able to test your project on. So I'm gonna bring up my project here. So I'm gonna place it right there. This is how we left the project in the previous chapter. And then I'm going to do Command Shift P on Mac, or Control Shift P in Linux and Windows in order to select the device. And I'm just gonna say iPhone 13 Pro, which is a simulator that I have here. Right there. And then I'm just going to go and say run without debugging. Okay. So this is going to take its time. And I just thought to then use this time to explain a little bit about extensions. As you can see here, extensions are the ability for a programmer in Dart in order to, or they're the ability for the programmer to extend or add functionality to an existing class. In chapter 6, we talked about classes and objects. So I kind of would wish for everyone who is in this chapter to actually have followed that chapter as well. I'm actually going to go here and go to Do Not Disturb. Yeah, I am actually there. So let's have a look at a simple extension in Dart and how we can use it. I can see that a program is running. I'm going to delete the old code that we had, and I'm going to bring my face to the bottom right. And I'm just going to be a little bit aware of these captions that I'm displaying on the screen and that they're blocking the screen. So I'll just make sure that you can see the contents as we go on. So let's also remove all of that, and then let's just say that we have a simple cat class here who has a name, and we can go in here and say final meow is an instance of cat, and then I can say print meow. Actually, we have to provide a name, I can see here, and let's just say fluff first, and we say meow dot name. Okay, so we print that name, and I'm gonna say command S, just like that, and I'm perhaps gonna bring up Visual Studio Code so you can actually see the output. So command S, and you can see that where are we getting this? There are equals. Oh, that's an old command. So command S, and you can see fluffers is printed to the screen. So that's because we have the name here. Okay, so I'm also going to get rid of this caption right now so you can see the entirety of the code. So like that, bring it down here. And I'm also going to get rid of my simulator and bring it to another screen. Okay, so now let's say that you want to add a functionality to this, or a function to this class that allows a cat to run or allows a cat to jump. So one way to do that is to actually go to the cat class itself and create a function in there. But what you can also do is to go and say extension, for instance, run on cat. That's the syntax for creating an extension. What you're saying is that you're extending the class call cat with a new functionality that is called run. Now, this is not the name of the function itself, it's just the name of your extension. And you don't have to really know about the name right now so much. It's just when you then go and become more advanced in Dart and you, for instance, create libraries for yourself, then you create extensions on different classes, for instance, in your library. And then people or programmers who use your library, then they can basically include specific extensions that you've included in your library in their code, or they can exclude them. So just know that it's just a name on the extension, so it doesn't mean so much right now. Okay, so then you can just create a function that has no return value called run, and then you can say print cat name is running. And you know this syntax from the previous chapters, that this is how you format a string. And then in here, you're basically doing string interpolation, I think it's called. And you're including that name inside your own string. So the result is going to be cat space, the name of this cat instance space is running. Okay. So using that, then every cat instance in your project is going to get that function called run. So you can just say meow run and then command S, and you can see that it says cat fluffers is running. So just know that extensions are they're a great tool for you to use if you believe that there is a functionality that you're adding to an existing class, which it doesn't really belong in that class itself, but it may, for instance, belong in the current source file that you're working with. So extensions are very, very useful. But I also believe that they need to kind of be used with care, kind of like sparsely. So when you really need an extension, you could just go and create an extension. And they have limitations. And as you get more used to programming in Dart, you will understand their limitations a little bit better. So just know that they're there and can be used. Another example of an extension is, for instance, if you had a class person, and say first name property, okay? So this is an instance property, and then you would say last name, and then you say command dot in Visual Studio Code on Mac or control dot in Linux and Windows, and you create a constructor for your person class. Okay, so that's how you create an instance of your person class. Then you can go in here and you say final foo is person, whose first name is foo, and whose last name is bar. Okay. And in here, let's say you want to be able to calculate a person's full name. All right. So what you could do is you could say extension full name on person. And in here, you could just say, I want to calculate the full name. So that the result type is going to be string. And then you want to create a getter. Now we haven't talked about getter so much, but just know that it's kind of like a property. It's a property that can only be read from, but it cannot be written to. So you just say get, and then you say full name as the name of the property, and you would say that is equal to dollar first name space dollar last name. Okay. So what you're saying here is that I have a getter whose return type is string and whose name is full name, and it returns the first name and the last name, all right, with a space in between. And then in here you could just say print foo full name, all right. And command S, then I'll remove the caption so you can see that foo bar is printed to the screen. Okay. So that's for extensions. And I'm gonna note that here in my, I'm gonna mark it in my notes that we've talked about extensions, all right? Now, the next thing to talk about, the next topic is futures. And as you can see here, future is data to be returned in a future, as its name suggests. So, and that is part of something called asynchronous programming. If you haven't been doing programming before, you may not be so familiar with the terms synchronous or asynchronous. A synchronous task is a task that happens when you ask for it, and it returns with the data that you ask for immediately. For instance, if you say, what is 2 plus 2? Then we'll say, okay, it's 4. That's a synchronous task. But if you, for instance, say to your spouse or to your friend, go to the grocery store today, please, and get some milk. That is not going to happen in this instant. Even if the grocery store is right next to your house or your apartment, then your friend has to go get ready, put on shoes, go to the store, get the milk, and come back. So that is an asynchronous task. So an asynchronous task is basically a task that whose results are not returned immediately. Okay, so up until this point, we've looked at functions that I'm actually going to remove all of this code from here so that we don't have all of that. Now we only have the void test function in here. Okay, so all of the functions that we've written so far have been synchronous functions. In that, for instance, you would say string multiplied by 2, and then it gets an integer of a, and it just says a multiplied by 2. All right. Int. So it returns an integer. The function name is called multiplied by 2. It takes an integer as a parameter and just multiplies that integer by 2 and returns it. It's a synchronous operation. Okay. However, in Dart, if you want to work with asynchronous operations, that you have to use a class called future. So let's have a look at that. Let's say that you have a function multiplied by 2. which it may take some time in order to multiply a value. Okay, this is hypothetical because the multiplication is going to be done immediately, but we're just going to assume that this is a complicated multiplication and it will take some time. All right, so let's say future, and then you would say what is the actual future, what does it contain, what data type, then we say integer, and then we say heavy future. Okay, and it takes a value of int, a heavy future that multiplies by 2, something like that. Okay, so it says I return a future. Okay, now in here, then your responsibility is to create and package up an integer and return it inside a future. So if you, for instance, in here say, okay, return 10, okay, you see that it says, oh, 10 isn't compatible with a future of integer because 10 is a synchronous value. It's right there, it's present. So what do you do in here? Then you could say, okay, what I do return is a future. And then you could say, oh, I'm going to delay this future by a duration of 3 seconds. Okay. And then you'll see there's a second parameter to this delayed function. You can see it. Let's see. If we have a look at delayed function in here, you see there is a second parameter called future or computation. So in here, what you need to do is just to say, okay, my second parameter is a function. I'm going to ignore its return value, but I'm just going to return the value of a. Okay, so let's actually see if we say future delayed duration seconds, and then we say the parameter is, let's say, e, and then I'm just going to say return a. What is this value going to be then? You know what? We could actually look at the documentation for future delayed, so I can also refresh my mind. So I'm going to go and open a new Safari window, and I'm going to say future delayed. And this is the type of stuff that usually happens anyways if you're programming with Dart. I'm also going to increase the size so that you can see it a little bit better. And let's have a look at a future delayed here. And here we can see how it's constructed, how to use future. Okay. So you can see here, then there is a function that it doesn't basically take anything, any value. So I think the problem was that I may have just created like a function that was expecting a parameter. So this is how you would do that. And I mean, it is a little bit strange. Like I'm actually going to clean it up a little bit as well. And then make this a constant. As you can see, it's suggested here, and then return. So I've written a lot of code. I haven't explained really what I've done here, but I will do that now. So let's see. We're saying that we're returning an integer in the future. So it's not going to be returned immediately. It's going to take some time for it to do its calculation. Okay. So, and in here, let's say a multiplied by 2 as we promised in the function signature. Okay. So that's future int. This is the name of the function, so nothing magical about that. And then it takes a parameter that says integer a. In the function body itself, we're saying, okay, we're returning a future, but we're delaying its return by the duration of 3 seconds. So duration, as you can see, is a class here. If you go in it, actually is a const duration, okay? And then there's a class on top probably somewhere. Let's see. Const duration, int, blah, blah, blah. Const duration operator. I believe this is, I mean, the duration Dart, it's probably just a class duration somewhere. If you look at here, class duration. So we're saying that we're creating a duration as the first parameter to the delayed function of the future. So we're saying that we're delaying this future's return value by 3 seconds. And then it says, okay, I'm going to wait 3 seconds, but then after I waited 3 seconds, I'm going to call this function. And this is kind of like a shorthand for creating an inline function. You could also do it like this. You say, okay, my function that I'm providing to this function. So it's like you're passing a function to the future delayed function. And then in here, you could just say, okay, I return a multiplied by 2 and then a semicolon. So this is probably a little bit easier to read. So now that we have that, we could actually use this function in our test function. So when you then, I mean, now that actually we've now talked a little bit about future, and in order to use a future, then you need to know something about async and await in Dart. Now, async and await are very related to each other, but quite different in their meaning. And um, I just want to now explain actually first async. Async is a keyword in Dart that marks a function as asynchronous. In that, remember, synchronous is something that returns immediately, and asynchronous is something that does not return immediately. It takes some time. However, to mark a function async in here, it means that this function internally can execute commands that do not return immediately. Okay, so async, marking a function as async, it it means that this function internally calls other functions that do asynchronous work. So let's now say final result is heavy future, and we say 10. Okay, now that we've done that, let me just print the result, and you'd be surprised to actually see the result. When we do that, you'll see that it is not what you think. It's not going to be 20. Okay, so I'm going to get rid of this caption so that you can see the result, and I'm going to clear the results in the console and Command S, and you'll see that what got printed to the screen is actually the future. Is not what you think. It's not the value 20, which should be a multiplied by 2, which should be 20. So what happened here is that when you call a function that returns a future, you're actually getting the future back. You're not getting its data back. So how do you get that data back? Well, by prefixing the function with the keyword await. So as its name indicates, this keyword is just going to wait for the result of this function to be calculated, and then it's going to go to the next line. Okay, so these two are very related to each other, and you'll see that if I remove async, then I will get an error saying that, well, you said this function called test is a synchronous function. It just returns void, basically means it doesn't return anything. And it's asynchronously does its work and doesn't have to wait for anything. So but then inside the function, you're saying await, which means, yeah, I have to wait some time for something, and that's not okay. So what you need to do then is you mark your functions with async if internally in that function you're using await. All right. And await itself then is used for waiting for the result of a future. Okay. So if you remove this async and then you remove this await, everything will just work. But it's just synchronously getting the future of the heavy future that multiplies by 2 and printing it. So it's not doing any asynchronous work in here. You can see it's just getting that instance. So now that we're calling that, let's Command S, and you'll see it's waiting 3 seconds and then printed the result 20 to the screen. Okay. So that for us was async and an await, and we're going to use async and an await quite a lot in this course. So it would be really good if you could have, with this information that I gave you, if you could just have a little bit of a read about future, like documentation on the web. So if you just search future Dart and maybe async await and read a little bit about them, because they're so important in doing asynchronous work in Dart that we just can't jump over them. Okay. All right. So now we've talked about future, uh, and we've talked about async and await. So I'm just gonna mark them as done in my notes. The next topic to talk about it would be streams. So, as you saw here, a future in Dart is a class that controls the computation of an asynchronous value in order to be returned in some point in the future. However, quite often in your client's work or even server work, you need to do work that is asynchronous. However, it is continuous work. For instance, if like I have the time displayed on top of my screen on the right hand corner, that is a stream of strings. It is a stream because it doesn't have an end really. It's a continuous pipe of information. Every minute that little ticker up on top, right, is gonna increase, and it's gonna go to 0650, 0651. So it is continuously calculating the current time and like sending it down at this pipe. Now, in asynchronous programming and in reactive programming, which you may also get into if you're following with this course, or if you're following some other course, you may actually be interested in learning more about streams and reactive streams. A stream is just a pipe of data that either completes or it never completes. Actually, it completes successfully, or it never completes, or it errors out and dies. Okay, so a stream of time up there, you can see it's now 0650 in the morning. It is a stream of data that never completes, because time is just continuously going forward. Okay, so when we talk about streams, we just mean a pipe of data, a future that sends data down this pipe that never ends. As you saw in the case of a future ends. It calculates its data and it returns and it says, I'm done. But a stream in Dart is a future that just continues working. Okay, so it calculates some data in the future and it also sends it down the stream and it says, oh, well, I'm not done. Here's another data. Here's another data. Okay, so let's have a look at this stream and see how we can work with streams. Okay, so let's go and create a stream of, let's say, string. And then we say get name. Okay. Now in here, your job is to create a string. So if you say return hello, see that hello is not compatible with the return type that you promised. It's going to be a string. So this is very similar to how we worked with the future of integer. You couldn't return an integer in that future, but you had to create a future of integer, and inside the function return the actual integer, which was the computation. If I go back, you will see that code here, right? The future delayed, and inside this function, you're actually doing the computation. All right. So how do we create a stream? Then you could just say stream, and then you could say, okay, periodic, for instance, or a value. Okay. If you say we return a stream of value, and then you could say foo, this is accepted. What this means is that you have a pipe of data, but the only value that it contains is the value of foo. That's it. All right. So let's now go into this test function and try to consume this stream. If you just said final value is get name, and you just print this value, and then I'm going to clear the logs here and say command S, you'll see that just like future, it just says instance of controller stream. Okay, so it is not the actual value inside the stream. So the question is, how do you wait for values inside a stream? You could just say, okay, await. And it says, okay, we could read this, await applied to stream string, which is not a future. So Dart is understanding that, okay, you're awaiting on a stream, but this is not just like a future that you could await for. There's nothing to await, like it's not a single value, is a stream. So the syntax to do that is await for. Okay, so this is a syntax for awaiting for values inside a stream. Then you could say await for final value in get name. Okay, and then you could just print the value. So this is a little bit of a strange syntax, but if you read it in English, it makes perfect sense. You're awaiting for values in get name. If you just ignore the final in here, okay? But read it in English from left to right. Await for values in get name. That's it. And then at the end, I'm gonna say print stream finished working. Okay. Clear the console, command S, and you'll see it immediately said foo and then stream finished working. I'm gonna clear it, command S, foo, stream finished working. Okay, so this is an interesting concept, but it's still not a stream really. I mean, we're packaging the foo string inside the stream, but it's only one value. We could have done that with a future. So let's take advantage of stream's actual functionality of sending down data in its pipe continuously. So what we could do in here is say stream periodic. It means periodically produce values. And in here, you can see the first parameter is a duration. So let's say constant duration of seconds every second. Okay. And then there is a second parameter in here that you'll have to provide. If I move my mouse over periodic, you'll see that the second parameter is this string function int. Okay. So it means that give me a function that accepts an integer and then it returns a string. All right. And it understands that it needs to return a string because you're saying that your stream is a string. If you change this to an int and then went here to the documentation, and the documentation will actually, or the method signature will change to say that you're supposed to take an integer in this function that you provide to me, and then you need to return an integer. Okay, so that string, I just wanted to show you that string that was shown in the function signature there, it's because we promised to return a string in our function. Okay, so let's go in here. Basically, the function signature said that you need to accept an integer, so I'm just gonna say value, and then let's go in here. I'm just gonna say return foo. Okay. So we basically conform to that function signature. We said we take some value, and you see the value is an integer, and then we're returning a string. Okay. So now we can consume that. So if I clear this log and I say Command S, you see that every second the value of foo is going to get printed to the screen, and that's actually, I need to remove this caption. I can see you can't see it. You see that 10 times, 11 times, 12, 13, 14. So, all right. I'm sorry about that. The caption was blocking the screen. I wasn't aware of that. Or actually, I was aware of that, but I forgot that that was the case in this as I was talking. So you can see that every second the stream is sending a value. All right. Now, that's basically the gist of using streams. I'm wondering actually if we're gonna use the streams in this course. I believe at some point we are. I need to probably um, look at my notes. Yes, I can see that we're actually using streams in this course. So don't worry about if you don't fully understand streams at the moment, because we're gonna talk about streams and um, because we're going to actually talk about streams and stream controllers later in this course. So just know for now that a stream is like a feature, but it continuously or periodically can return values, and then you can wait for those values using the await for syntax in Dart. Okay. Now the next topic to talk about in this chapter is generators. So generators are very, very interesting in Dart. Some other languages also support generators, but not all modern languages do that. So a generator in Dart is a function that returns, I don't want to say iterable, but it returns a list of things, but it internally calculates that data in a very simple way. That's the best explanation I could come up with, to be honest with you. Let's have a look here. I think the best way to do that is actually write a function that does creates a generator. Okay. I'm gonna clear this, and then we have a test function here. Let's mark with async. Okay. Let's now go create a generator, and let's say we want to create a function that returns the values 1, 2, 3. So a way to do that would be to say I want a list of integers, okay, and my function or get 1, 2, 3 like this. And you could say return 1, 2, 3 like that. Okay, so that's completely valid. Another way of doing that is to use something called iterable. And iterables, I mean, you need to understand what iterables actually are in Dart. They're kind of like lazy collections. And when you get used to doing more software engineering, you will understand more why we use lazy collections. But for now, just know that an iterable is a prepared and packaged up list of things, but it is not completely calculated when it first begins. It's kind of like how a restaurant works. In a typical night, a restaurant might have, for instance, 50 customers, and when that shift begins during the night, not all food is ready. I mean, it can't possibly be like when the first customer comes in, we can't say that the food for the 50th customer is already ready in the kitchen. That's how a restaurant works. It listens to orders of its customers, and then it generates the food based on the orders. That's how an iterable works. Okay. However, a list in Dart is an already packaged list. It means that it's as if like you go to a supermarket and then you buy ready to go food that's already packaged, 30 packs of that. That is a list. That is 30 readily packaged food items, and then you take away. That's how a list works. But an iterable is more like it's a list of like things that gets calculated on the go, on the fly. All right. So um, just know that for now. So we just said iterable, and as you can see, Dart understood that. Okay, a list is also an iterable, so I don't have to worry about that. So it didn't give you an error. So let's go and actually, instead of doing 1, 2, 3, let's go and mark our function as a generator, and you do that with either sync or async. Okay, so and this would be a stream. Like now, the difference between sync with an asterisk and an async with an asterisk is a sync function is a generator function that returns a list of things, but it calculates that list of things synchronously. And as you can guess, the async equivalent of the sync asterisk, it does the exact same thing, but it returns a stream, and which means it's asynchronously calculating its result. Okay, so when you mark a function as sync, you don't then go and return like this, because you can see that it says you're creating a generator function. So you have to kind of calculate your results now. You can't just return a bunch of things to me. Okay, so to do that, you would use a keyword in Dart called yield. Now, yield is a very interesting keyword that you would use only in generator functions, as far as I know. And in here, you're telling Dart that, okay, the first value that I'm outputting in my iterable is the value of 1. So if in here we went and said, I don't, or say we say for value in get 1, 2, 3, and then you could just say print value. You can see it only prints the value of 1. I'm actually going to get rid of this caption. You can see the output. It only prints the value of 1 just because we yielded the value of 1. Okay, so you could just then say yield 1, yield 2, and yield 3. Then you'd see the values 1, 2, 3. So in this function internally, then you could do a lot of other important things, maybe some other synchronous calculations. And every time you have a value to output, then you would basically you would do a yield. And you could also print the entire return value like this. You don't have to do a for loop. So you could just say print it, and then it will say 1, 2, 3. Okay. But if you do a for loop, then you're actually taking advantage of that lazy capabilities of an iterable. So you could break out the loop at any time. You could just say print value if value is 2, then you could break. Okay, so let's clear the logs and Command S. You'll see only the value of 1 and 2 gets printed, and then as soon as you're at the value of 2, then you're breaking, and that means that this yield was basically never calculated. So that's like the beauty of generator functions. So you could also create asynchronous generator functions, as I mentioned, and that means that you're kind of like creating a stream of iterables. To be honest with you, asynchronous generators, I've maybe used them once or twice in the many years I've used Dart. So I don't think you're going to use them a lot, but just know that they're there, and you could use them by prefixing your iterable with a stream. saying that basically you're returning a stream of iterables and then suffixing your function with async, just like that. All right. So, and then here it says, okay, you said that you're returning a stream of iterable integers, but you're returning only one value in here. Then you would just say, okay, 1, 2. Okay. But then you would say, yeah, then you have the ability to do whatever you want here, like return an actual iterable. Okay. So I'm not going to talk about asynchronous generators, to be honest with you, in this course, because they're kind of like outside the scope. So just know that they exist and you can use them. Okay, I'm going to mark in my notes that we've talked about generators. So the next topic to talk about are generics. And I'm going to bring up a caption here. So generics in programming languages that do support it are there so that you avoid writing the same code over and over again, okay? So let's say that this is a very typical example. I know it's a little bit cliche, but I think it's cliche for a reason, and that's because it's such a good example. Let's say you have a class that stores a pair of data. Let's just say class pair, okay? And then in here, you could say, okay, what pair of data do I want to store? Okay, I want to store value 1 as a string, and I want to also store value 2 as a string, and then you create the constructor for it, okay? All right, that's great. It's a pair of strings, but how do you then pair an integer, like 2 integers? Then you would say, okay, I have to have another pair class, and this one is an integer. But then you have this problem because pair is already defined as a class up there on line 7. So you cannot reuse that. You cannot have the same name. Then you would say, okay, pair of integers. And then here you would say pair of strings. And then you make sure that the constructor name is also correct. Now, you may have also, in this point, at this point, we don't have logic at all in these two classes. You may have actually quite a lot of logic in your classes, but as I mentioned, I think during one of these chapters, I think it was chapter 1 or 2, one of the main characteristics of software engineers is that we all dislike uh, writing the same piece of code over and over again. So we try to, as much as possible, avoid repeating ourselves. So that's where generics come in. So what you could do is, instead of doing this pair of, let me bring this here. Let's go and create a class that is generic, and you would say pair. And then a format for creating a generic class is to, right after the name of the class, just do a less than and greater than sign, okay? And then open your square brackets. Now, in here, then you define your generic names, like the data types, usually with single characters. Let's say that what you want is a pair of any data type. Let's call the first data type A and the second data type B, because there's 2 values. So let's call this one A and this one B. Okay. You would just write them as we just say. We say A and B. Okay. So then in here, you would say final A value 1. So you're telling the compiler that, okay, whatever pair I'm creating, the first data type that I accept is A, and that should be placed here. And then we say, okay, then the B is the second one. And then we create a constructor for this, okay? So how you would use this then is you would say final names is pair, then you would say foo and bar, okay? And then this is just like a simple, it's very similar then to pair of strings that we wrote up there. You see, it works as well. But now in this case, Dart is smart enough to understand that names is a pair of string and string, meaning that the 2 values that you pass to this pair generic class were actually then placed for you magically inside the A and B templates that you provided up here. Okay. So if in this case, then you said, okay, I have foo, and then I have the value of 20, then Dart's smart enough to understand that, oh, now it's a pair of string and integer. So that's how you would use generics, basically. So I mean, there is so much to talk about generics and how you can basically utilize them in order to create very simple classes so that they're reusing as much capability or as much code as possible without duplicating that code. So, and talking about generics, to be honest with you, it could be its own entire course. We could go on 4 or 5 6 hours. I could talk about generics. So just know that generics are created like this. You say class pair, and then you would say your generic data types, which then in turn get placed inside the definitions inside the class itself. So okay. Um, all right, now that we've talked about generics, I believe that we could kind of like wrap up this chapter where we talked a little bit more about advanced topics in Dart, extensions, futures, async await streams, await for stream generators, and generics. Okay. Now, I'm actually really happy that we went through chapter number 7, which is this chapter, because up until this point, we've kind of been like preparing ourselves for launch. It's it's now time that we put everything that we've learned into practice and actually start building our project. So I'm actually getting goosebumps because it's such an important part of this course that we've actually gone through the basics. We've talked about Dart. We've talked about like some of the basics of setting up the simulator, etc., etc. That it's with great pleasure that I can say, okay, we've gone through that now, and all you need to do right now is just to practice. And what better way to practice than to put what you've learned into application by writing the Flutter project that we've been aiming to do from the beginning. So without further ado, let's then prepare for the next chapter, which is chapter 8. And in chapter 8, we're going to talk about project setup, and then we're actually going to add some dependencies to our project, which we're going to use later. Okay, so let's then aim for that, and I'll see you in the next chapter.